Also, one of the big criticisms of neural networks is that they can hallucinate, so that is, they can produce outputs that are not correct. So, how to avoid that? So, we will see some strategies. Some of the strategies are specific to large language models. Some others are general, can be applied to almost anything. So on the general tools, we have this improved training data, so use high quality, clean, accurate data to train the model. You can use data augmentation to improve the generalization. You can use domain specific data, so you have to be sure that your training data is relevant for the specific task that you are trying to train. You can use regularization techniques, drop out to avoid overfitting, weight decay, again to avoid overfitting, early stopping. Then you can try to use simpler architectures because they have fewer layers or fewer parameters, so that there is less possibility of doing overfitting. You can add attention mechanisms so that you concentrate on the input parts that are more relevant for your output. Then you can have also ensemble methods in which you combine the predictions from multiple models. You can do fine-tuning, so you pre-train a network on a very large data set, and then you only do fine-tuning with respect to the specific data set or the specific task. Somehow this is also kind of similar to this pre-trained strategy. And you can also do post-processing and constraints. So for instance, once the network has produced an output, you can apply some rules to filter out implausible or nonsensical outputs. You can do beam search. Beam search, especially in text generation, you explore multiple output sequences and you select the most likely one. Or this temperature scaling, in which you change the temperature parameter to control the output randomness. Again, this applies mostly to large language models or generative models. This human in the loop, so you incorporate the human for those outputs that you are more uncertain. So this active learning, so you ask a human what is the true label for this input data. Human review, use humans to review and validate the outputs before deploying. You can estimate the uncertainty, so you can put confidence thresholds and only accept outputs if there is a high confidence score, or you can use a Monte Carlo dropout to estimate what is the uncertainty on your output, or you can try to model the uncertainty explicitly with some kind of probabilistic method. Then you can use evaluations that are robust to hallucinations, or you can try to test how robust is your network with respect to adversarial attacks or edge case inputs. You can continuously monitor the outputs of your network and retrain if it is necessary. You can use this symbolic artificial intelligence, so something based on rules, so that you can validate the output of the neural network, or they cannot take advantage of external knowledge like these ones with knowledge graphs. Here we have a couple of examples. One is using knowledge graph, and then let's say that you have some nonsensical output, and So these are different ways of hallucinating. So having nonsensical output, having some irrelevant or random output, or prompt contradiction, or sentence contradiction, or factual contradiction, and you can use the knowledge contained in knowledge graphs to verify these facts, or to verify at to which level you are contradicting something that you already know. This retrieval augmented generation, it also helps to generate more accurate output. So the idea is that you have a user query, and then this user query you generate similar queries, and then from all these queries somehow you generate an output for each one of these queries, and then you have some kind of fusion of the results. And how to do that, that is again very domain specific. And then from these re-ranked results you take them as input for generating the final output. Then you can also, this is specific for large language models, so fact disambiguation. So identifying pronouns and vague entities. So for instance here we have he said the server would be fixed tomorrow. And then after fact disambiguation, then you say on October 10, 2024, John Smith said the server in the Chicago data center would be fixed by October 11th, 2024. So it is not he or tomorrow, but you nail down the details of those facts. Also, once you have the large language model already fixed, what you can try is to add these kind of verification loops. So ask the LLM to double check this answer regarding calculations and cross-reference to historical data, or you can ask the LLM to divide the answer into small steps and explain the reasoning behind each one of the steps, or use confidence scores so that it produces a confidence on how confident the algorithm is that that output is correct. And these tools you can use them after training your large language model, so you don't have to retrain to use this kind of preventers of hallucinations. Here we have the one that is related to temperature. So the temperature is used to choose which one of the possible outputs we will choose as the next word. So for instance, let's say that we start the sentence with the boy went to and the large language model has to predict the next word. So could be the boy went to the cafe, to the hospital, to the playground, to the park, to the school. And then as we increase the temperature, we can take any one of these possible outputs as the next word. So we have it here. So for instance, so the next word will be chosen according to this probability. So y will be these kind of numbers that we have there, and then depending on what is the temperature, so we can have a very entropic output or a very fixed output. So for low temperatures it is rather single the output. For very high temperature, almost all words are equally likely. So for instance here, I like red apples, or I like red shoes, pants, onions. So it could be anything, but if we lower the temperature very much, then the only outstanding word is apples. And Here is another way or to illustrate how low temperatures can incentivize the model to collapse, the probability distribution, and having less uncertainty. But on the other side, it is can lead very easily to false statements, and this is because what we are being is very greedy in this optimization of the output probability. So, for instance, uh, was Nicolas was Nicolas Cage born in an even or odd year? So the greedy path could be okay. It is an odd year and it has the highest probability in the greedy path. So every word here has been generated in a very greedy way with very low temperature, as we saw here. And we can keep the temperature higher, and somehow we can associate some kind of score to the output. So we have possible paths for the output. So one is just even, odd, 1964, an even year. He was born in an even year. Cage was born in 1964, an even year. So we have multiple paths, each one with a different confidence score, and the fact that we use multiple paths allow us later to choose the one with the higher score. If we are very greedy from the very beginning, then we don't have anything to choose from, and then we very easily can generate wrong answers. This would be it for the hallucinations. See you in the next topic.